So this podcast is about conjugate acid and base pairs. And we're going to use reactions to figure out what is acting as a base and what is acting as an acid. So what we do when we look at conjugates is follow the protons. And we're going to use the direction of protons to figure out what is acting as an acid and what is acting as a base. Remember that an acid loses a proton and a base gains a proton. So if we look at the forward reaction, we see that H2S loses a proton and becomes HS minus. So therefore, it acts as an acid and it loses a proton. Where NH3 gains a proton and becomes NH4 plus. So it acts as a base because it gains a proton. So in the reverse reaction, HS minus here gains a proton and NH4 plus loses a proton. So everything is the opposite. So the acid becomes a base and the base becomes an acid. And we call these pairs conjugate base pairs. So the conjugate base pairs are H2S is the acid, and then it has a conjugate base. And in the conjugate base, it has lost a proton. Then we have NH3 as a base, and it has a conjugate acid. And in its conjugate acid, it has gained a proton. So there's these pairs, and they're connected by one proton. So what we're going to do in this chart is, in the first column, you're given an acid, and you are going to label its conjugate base. So we're going to look at the acid, and its conjugate base is going to be minus one proton, and that's going to change the charge. It's also going to lose a plus charge. So what I'll do is pause the video and fill in the chart, and then turn it back on and check and see how you did. So here are the conjugate bases in this column here. So H2SO4 loses a proton, it's HSO4, and then it has a minus 1. So in each case it's exactly the same. NH4 plus is going to lose one of its protons, one of its hydrogens. NH3 in its charge also goes down. So its charge was a plus 1 and now its charge is 0. Water, H2O, is going to lose one of its hydrogens and become OH with a minus charge. This column over here, you're given the base, and you're going to do exactly the opposite. You're going to write its conjugate acid. So in its conjugate acid, it will gain one proton. So again, pause the video, fill in the list, and then turn it back on and check and see how you did. Check your answers. Okay, so here are the conjugate acids. Notice that O with a minus 2, that's a funny base, but it's definitely a base. When it gains a proton, it becomes HO with a minus, or the way we usually write it, OH. These are interchangeable. You can write it either way. So what we're going to do in these reactions is look at the entire reaction and follow the protons. So HCl loses a proton and becomes Cl minus. So we label the acid and its conjugate base. Water here becomes H3O plus, so water is going to act as a base because it gains a proton, and we'll label that one. So water acts as a base, and H3O plus is its conjugate acid. We always write the word conjugate on the right. It's just convention. It's to show that it's on the product side of the reaction. So acid becomes a conjugate base, base becomes a conjugate acid, and you're going to use the protons to be able to tell which is which. So again, pause the video, go through and label the next equation, and then turn it back on and check and see how you did. So NH3 acts as a base because it gains a proton, and this is its conjugate acid. And water here loses a proton, so water is the acid, and OH minus or hydroxide is its conjugate base. So do the next thing on the do the same for the rest of the reactions. Pause the video, check, write your answers in, and then turn it back on and check and see how you did. Okay, acid becomes a conjugate base, it loses a proton, the water acts as a base, and it becomes a conjugate acid. Last one. Nitric acid loses a proton, becomes its conjugate base, and water gains a proton and becomes a conjugate acid. And remember that water is amphoteric. It can act as an acid or a base depending on what it is with.